Alright, so welcome to the Algebra 2 LINSYS2 review. Alright, so for number 1 it says, for the following scenario, define the variables and write a system. So we have a theater sells adult tickets for $10 and student tickets for $6 and child tickets for $5.50. A total of $1,072.50 worth of ticket sales were collected. The total number of tickets sold was 135. If the number of adult tickets sold was twice the number of child tickets, how many of each type of ticket was sold? Alright, so first let's define the variables. We could use A, S, and C. Alright, so A, that's going to be number of adult tickets S is going to represent number of student tickets. C is going to represent number of child tickets. Alright, so we're going to set up an equation, then write the system as an augmented matrix, and then solve in the calculator. Alright, so let's start off with the first sentence. So they sell adult tickets for 10, students for 6, child for $5.50. And $1,072.50 is how much was collected from the sales. Alright, so from the first two sentences, we know that it's $10 per number of adult tickets plus $6 for student tickets, so 6S, and then plus $5.50 for children tickets, and that was a total of $1,072.50. Right, we also know that the tickets sold was a total amount of 135. So the amount of adult tickets plus student tickets plus child tickets was 135. So A plus B plus C, or A plus S, equals 135. Also, if the number of adult tickets sold was twice the number of student tickets, so the adult tickets sold was twice the number of children tickets, so A equals 2C. Here's, I want you to notice with these equations, you want all the variables to be on one side. On the very last one, we have the A on one side, the C on the other side. So let's subtract this 2C to get it to the other side. So we have A minus 2C equals 0. So this is going to be the one that we use when we create the augmented matrix. Alright, so for the first row we have 10, 6, 5.50, and the total is 1,072.50. Alright, from the second row we have 1 adult, 1 student, 1 child ticket. That total should be 135 tickets sold. And then for the second row we have 1 adult ticket, and then student tickets, there's nothing there about S, so put a 0 for S, and then minus 2 for C, and then equals 0. Alright, so now let's use the calculator to solve for this solution. So second matrix, go to edit, make sure you have a 3x4. Alright, the first row we're going to put 10, 6, 5.50, 1,072.50. Second row, 1, 1, 1, 135. Third row, 1, 0, negative 2, 0. Alright, so again we go second matrix, go to edit, make sure you have a 3x4, and then just type your numbers in. Alright, so I'm going to go back to the blank screen. go back to second matrix, but this time we're going to go to this second column, which is math. Look for RREF, the one with two R's. Then you should get this with an open parentheses, second matrix. Now we're going to go to names, input matrix A, and then we get the augmented matrix that's going to give us the solutions. I mean, not the augmented matrix, the reduced row echelon form matrix. So this is the solution matrix. The first row is 1, 0, 0, 70. The second row is 0, 1, 0, 30. The last row is 0, 0, 1, 35. All right, so this is telling us that we have 70 adult tickets. So 70 adult tickets were sold, 30 student tickets sold, and then 35 child tickets sold. Right, so write the solution using words from the scenario. Right, so I guess this could go here. Alright, so 70 adult tickets sold, 30 student tickets sold, 35 child tickets sold. Alright, so let's go to number 2. Write the following system as an augmented matrix. So all we're doing is converting this into a matrix. Alright, so 1, 1, negative 2, negative 11, 2, 0, 4, 15. Alright, you're missing the y value here, so just put a 0 in place of it. On the third row, we're missing an x, so we're going to put a 0 for the x column, 1 for the y column, negative 6, and then negative 35. Alright, so this is an augmented matrix. It's the matrix that you get when you convert from a system to a matrix. Alright, so now for number 3, find the x value of the solution set of the system of equations below. So we know z is 2. Let's use this 2 to find y. So y minus z equals negative 5. Y minus 2 equals negative 5. Since z is 2, add the 2, y equals negative 3. So we have z and y. Now let's insert those into the first equation. So x minus 2, in place of y, we put negative 3 minus 2 times 2 equals 6. Alright, so negative 2 and negative 3, when you multiply them, you get a positive 6. Negative 2 and positive 2 make a negative 4 equals 6. 6 minus 4 is positive 2. X plus 2 equals 6. Now subtract the 2. X equals positive 4. Right, so now for number 4, write the system of equations that represents the matrix. So all we're doing is converting the matrix back to a system of equations. So the first row is x, y for the second, and z. Alright, so we have 3x plus 12y. There's no z because we have 0 there, equals negative 4. No x, so 2y plus 9z equals 6. And then for the very last row, we have 3x plus 4y minus 7z equals 11. Alright, so all we're doing is converting the matrix back to a system, and now we're done. Right, so number 5 says, find the solution to the matrix given below. Use back substitution to write as x, y, and z. Alright, so we have the system, or we have the matrix. Let's convert it back to a system. So the first row is 1x minus 2y plus 3z equals 13. The second row is just y equals negative 1. The third row is telling us z equals 2. Right, so we know y and z, all we have to do is find x. So we have x minus 2 times negative 1 plus 3 times 2 equals 13. Right, so negative 2 and negative 1, a negative and a negative make a positive 2. 3 and 2 make a positive 6. 2 plus 6 is 8. And then last step, subtract the 8. So subtract the 8, we get x equals positive 5. So the solution here is 5, comma, negative 1, comma 2. Alright, so for number 6, what is row echelon form for a 2 by 2? Alright, so row echelon form is just when you have a diagonal of 1s, everything below it's a 0, and then you have some numbers up here. Alright, same thing for a 3 by 3, you still want that diagonal line of 1s. Everything below it's a 0, so then number, 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 some numbers, some number, some number. Now reduced row echelon form is when you have zeros above and below the ones. Alright, so 1, 1, 1, 0, 0, 0, 0, 0, 0, and then the constants, those could be whatever numbers. Those numbers are going to be the solution. Alright, so these numbers here would be the solution. Alright, so then for number 7, finish solving the matrix using Gaussian elimination, state the row operations, and write the answer as an ordered pair. So step 1, do we have a number 1 on the top left? Yes. Do we have a 0 underneath it? Yes. Now this number has to become a 1. So if you want to make something a 1, just multiply by its reciprocal. Negative 1/9 times the second row. So the first row stayed the same. Negative 1/9 times 0 is 0. Negative 1/9 times negative 9 is positive 1. And then negative 1/9 times negative 72, that should be positive 8. Alright, so for the first row we got 1x plus 2y equals positive 18, and y equals 8. Alright, so we're gonna plug 8 in for y. 2 times 8 is 16. Now subtract the 16 to get the x by itself, and we get x equals positive 2, so the solution is 2, 8. Alright, so now for the last page. Alright, so for number 9, Tracy, Danielle, and Sherry bought snacks for a girls' sleepover. They each bought the items shown in the following table at the local convenience store. So they have number of bags of potato chips, number of liters of pop, number of chocolate bars, and the cost. Alright, so here we have what the variables represent. C is the unit cost of the potato chips, P is the cost of pop, P is the unit cost of chocolate bars. So express the problem as a system of linear equations and a matrix. Alright, so as a system of equations, this would be 4C plus 4P for cost of pop, then plus 6B equals 21. Alright, so then 3C plus 2P plus 10B equals 20.88. 2C plus 3P plus 4B equals 1317. Alright, so then just convert this to a matrix. Alright, so we have 4, 4, 6, 21 for the first row, 3, 2, 10, 20.88 for the second row, third row 2, 3, 4, 13, 17. Alright, so now we're trying to solve the system of linear equations and show the unit cost for each type of snack. So let's use the calculator and put it in row echelon form. Alright, so let's go back to second matrix. Go to edit, make sure you have a 3x4, 3 rows, 4 columns. We have 4, 4, 6, 21 in the first row, 3, 2, 10, 20.88 in the second. Third row, 2, 3, 4, 13.17 for the third row. Now go second quit, back to the blank screen. Now second matrix again, go to math, go down to RREF, go back to second matrix, insert matrix A. Alright, so here we have the cost for each snack. Alright, so by looking at the matrix, we could see that the cost of potato chips chips is $1.98. The cost of pop is $1.47. Cost of chocolate bars is $1.20. Alright, so then for number 10, we are going to convert the matrix to the system to an augmented matrix, RREF, and then the solution. Alright, so for the first system, the first row is -3, 2, -13. Second row, -2, 1, -8. Alright, so I'm going to put this in row echelon form. So second matrix. Alright, this time we have 2 rows, 3 columns. First row is -3, 2, -13. Second row, -2, 1, -8. Alright, go back to the blank screen, then go back to second matrix. Go to RREF, second matrix again, input matrix A, and then we get the solution. Alright, so our solution is 3, -2. Alright, now same thing for number 11. First row is 1, 1, -2, 11, or -11. Second row, 2, -1, 4, 15. Third row, 3, 1, -6, -35. Alright, so now let's find the solution matrix. So second matrix, edit, this time we have 3 rows, 4 columns. First row contains 1, 1, -2, -11. Second row, 2, -1, 4, 15. Third row, 3, 1, -6, -35. Alright, second matrix, math, RREF, second matrix, insert matrix A, and then enter, and then you get the reduced row echelon form matrix. Alright, so the first row is telling us that x is negative 2, second row y is 1, third row z is 5. Alright, so now for the last two. Solve using substitution or elimination. Alright, so for number 12, let's use elimination. Here we have a negative 5y, so all we have to do is make this y a positive 5y. So let's multiply this row by 5. When I multiply that row by 5, 5 times 4 is 20x, 5 times y is plus 5y, 5 times 42, that is 210. Alright, so let's conduct the elimination. So the y values go to 0. 6x plus 20x is 26x. 50 plus 210 is 260. Divide by 26. Then we should get x is 10. Alright, so x is 10. Now let's use one of the original equations to find y. I'm going to use the first one because the first one already has y by, there's not a number in front of the y, so it's easier to use this one. So 4 times 10 plus y equals 42. Alright, so I'm substituting 10 into the first equation. We get 40 plus y equals 42. Subtract the 40, y equals 2. Alright, so we have the solution of 10, 2. Alright, so now for number 13, I'm going to use substitution because the y value is already isolated. So I'm going to substitute this in for the y value. So 3x minus 2, parentheses, 5 minus 2x equals 11. Alright, so be careful here. We're going to distribute this negative 2. We get 3x minus 10 plus 4x equals 11. Alright, so the negative 2 and 5 make a negative 10. The negative 2 and negative 2x make a positive 4x. Now combine your like terms. You get 7x minus 10 equals 11. Add the 10. Once we add the 10, we get 7x equals 21. Divide the 7, x equals 3. Since we already have an equation up here that has y equals, let's use this first one to solve for y. So x is 3, so you could write this as y equals 5 minus 2 times 3. Alright, so we're substituting the 3 into the first equation to find y. So y equals 5 minus 6. 5 minus 6 is negative 1. So our solution is 3, negative 1. And that's the end of our review.